Alright, we are beginning Chapter 8. This is Section 8.1, which is Operations with Functions. So I'd like to start by reviewing what a function is. Definition of a function is a special relation where each input has a single output. So another way to say that is each x has only one y. We also, if we're looking at the graphs, we know that to be a function it has to pass the vertical line test, where the vertical line will only cross the graph once. This next table, it's from page 332, is what I call a reading lesson. When you are doing operations with functions, you could be adding them, like this first one. And when you add functions, I want you to be able to see that you could add the functions together and then put a number in, and that would be the same thing as putting the number in separately to each function and finding each input and adding them at the end. So when you see this, f plus g, I want you to be able to read it as f of x plus g of x. Likewise, when you're subtracting the functions first and then putting the x in will give you the same value as if you put the x in and then subtracted the two outputs. When you're multiplying, same thing. You can find the two outputs separately and then multiply them. Now here, when you're dividing, this brings up something new, something different. When we have a denominator, we need to be able to say whatever the excluded values are. An excluded value would be anything that makes this denominator 0. Because remember, in our number system, we cannot divide by 0. So for instance, if you had a function that had something up here on top, say 4x plus 1, and then on the bottom we had x minus 5. The excluded value would be whatever makes this denominator 0. In this case, it would be a 5. So x cannot be equal to 5 is how we would state that, so that the 5 is eliminated from the domain. And again, the reason is because we cannot divide by 0. Alright, in this first example, we're given a function f and a function g and asked to find the following things. First, we have to find f plus g of x. So we look here in this x part, there is no number. So it does mean that we're just working with the x's and we're going to be just adding these two functions. So in order to add them, well, let's just write it out here. We would have x plus 1 quantity squared, and we are adding to that x minus 2. So this is correct, but it's not simplified. In order to simplify this, we need to FOIL out this function f, because it's x plus 1 times itself, x plus 1. So foiling that, we x squared plus 2x plus 1, and then I'm adding to that an x minus 2. So now we combine like terms, and our final answer would be x squared plus 3x minus 1. And that's just the new function, that is the f plus g of x. Moving on to the subtraction. It's kind of handy if you keep track of your foiling. So I'm just going to copy down my foiling from the part A, and I'm going to write x squared plus 2x plus 1, but now we're subtracting, and I'm going to put the g, that function, in parentheses so that I realize I do need to distribute that subtract sign. So now when I combine like terms, I get x squared, and then 2x take away 1x is 1x, and I got 1 plus 2, which is 3. So that's the final function for my f minus g. Well, it looks like I put a minus sign. It needed to be a plus sign. Sorry. All right, the next one, when we're multiplying. Again, keeping track of my FOILed version of the function f, I'm going to put x squared plus 2x plus 1, and now I need to multiply that by the g function, which is x minus 2. So now I need to remember my algebra. This is more than FOILing. It's got 6 multiplyings to do. So if we multiply this, first we multiply the x times everything in the trinomial, and we would get x to the third plus 2x squared plus x. And then if I multiply the negative 2 times everything in the trinomial, I would get negative 2x squared minus 4x minus 2. So now combining like terms to get my final answer, I would end up with x to the third. The x squared terms subtract away, minus 3x minus 2. And then for the third function we're supposed to do with f and g, we are to divide them. But this time, instead of using the factored, the FOILed form, I'm going to use the factored form of x. So x was x plus 1 quantity squared, and g in the denominator is x minus 2. Now if you don't have the factored form of your numerator, then you have to factor it, because we want to look to see if it's possible for us to cancel or divide away this entire factor, this entire denominator. So since we have an x minus 2 in the bottom, if we factored it and we had an entire x minus 2 in the numerator, we would cancel them. But as it stands, there is no canceling here, so this is simplified. We simply need to state any excluded values. And in this fraction, 2x equal 2 would make the denominator 0. So we have to exclude that from our domain. So x cannot equal 2. All right, this is the second part of 8.1. This is called the composition of functions. That little symbol that looks like a, well, kind of looks like a degree symbol, that stands for of, where, like this is f of g. And it literally means you take this function g and put it inside the f. So sometimes I'll draw little arrows here to indicate take the g and put it inside the f. And that's what this symbolizes, taking the entire function g and putting it inside the f. And then vice versa, we can take the entire function f and put it into the g. So really do write this down in your notes if you don't have it, that fog puts g into f, and goff, vice versa, puts f into g. So now we're given that the function f is x squared plus 3, the function g is 2x plus 1, and we need to find both. We're going to do both fog and goff. So we're going to find this function g, we're going to put it inside the function f. So we're going to take this g, this 2x plus 1, and we're going to put it inside right there where that x is in the function f. So we have to square the x, we're going to put in this whole thing, 2x plus 1 quantity squared, and the next thing that f says is I need to add a 3. So to simplify it, we FOIL this out and then we'll add 3 at the end. So 2x squared is 4x squared, and then I have 2x plus 2x is 4x, and 1 times 1 is 1, and then I have a plus 3. So when I simplify this, just a matter of combining the numbers, I have 4x squared plus 4x plus 4. And that is the function fog, that is g put inside f. So now we're going to come down here and do the vice versa. We're going to take this function f, this whole thing, and we're going to put it in right here where the x is in the g function. So I'm going to take this, it says 2 times x, take the 2, and then put where the x is the entire f function, x squared plus 3, close parentheses, and I have plus 1. So here just distribute the 2, 2x squared plus 6 plus 1, so all that's left to do is combine your 6 and 1, and we get 2x squared plus 7. Alright, please note, now that we have finished Fogg and Goff, notice they are not the same. You're going to get very different functions when you flip these around. So Fogg and Goff are not commutative. Alright, in this last part we're going to look, part C and D, we're still using the same functions, f and g, and we're going to be putting in some numbers now. So perhaps it would be helpful for me if I just wrote that to remind myself. So f of x is x squared plus 3, and we had g of x, 2x plus 1. So now when we have a number, we don't have an x here, they want a certain input. This input is 2. This is what I call the leapfrog technique. We can take this input of 2 and put it into the g function, get that output, and then put that into the f function and get the output from the f. So it's like a leapfrog system. So first let's take the negative 2 and let's put it into the g. And I'm writing it down, but most of you will be able to do this with mental math. So negative 2 times negative 2 is negative 4, and negative 4 plus 1 is negative 3. So now this becomes the new input. We have the negative 3 right here, so we take the negative 3 and put it into the f. So taking the negative 3 into the f, we square it, and we will be adding a 3. Negative 3 squared is positive 9, and 9 plus 3 is 12. So that's my final answer. So f of g of negative 2 is 12. So now down here, a different example. Again, we can use the leapfrog technique, taking the 3, putting it into the f, and getting a different output. Taking that output, and it becomes the input for the g. So starting, we take the 3, put it into the f function. Becomes 3 squared plus 3. Again, 3 squared is 9, plus 3 is 12. That becomes our new input. We take that 12 and put it into the g function. 2 times 12 is 24, plus 1 is 25.